Hello and welcome to your second lesson in the absolute values unit. Today we're going to look at absolute value equations. So last lesson we learned what an absolute value is, and then today we're just going to use that knowledge to apply it to solve absolute value equations. Then our third and last lesson in this unit is to graph them. So much shorter than the radicals and rationals. So it is getting better from here on, I promise. Okay, so last lesson we learned the definition of an absolute value. So we said that an absolute value of a number is always positive. The official definition is if the number is positive, it stays positive. If it was negative, you make it negative. So negative is positive. Fancy way of just saying the absolute value of a number is always positive. Remember my visual of walking left and right? Because absolute value talks about the distance from a reference point in the middle, 0. Doesn't matter what direction you go, that's why it's positive. If you took physics, then you've done a lot of work with that, so you have maybe a little bit more background experience with absolute value numbers. But in case you didn't take physics, that's why an absolute value is always positive. So today we're going to solve absolute value equations. So very simply, let's look at a simple example. The absolute value of x is c. How do we solve that? Well, the first thing you have to realize is you have to solve two equations. You have to solve for x and negative x, because based on what we just said, the absolute value of a number is always positive. So if that's true, the x could have been positive, but the x could have been negative. If that didn't make sense, then let's look at this example here. If I say the absolute value of x is 5, well, what's our x value? You should realize there's two answers. X could have been a positive 5. The absolute value of positive x, or positive 5, is just 5. But you have two answers. X could have also been negative 5. The absolute value of negative 5 also gave positive 5. So when we're given this as an equation to test back what was the original equation or part in there, you have to test both branches, because that could have been positive or negative. So we do have to test both. That's all that's saying there. And then once you test and solve, you do have to do your check at the end with a t-chart, but we've done t-charts for several units, so the rest should be pretty straightforward. This is the only new step we're adding. Okay, so let's try a few examples. So our first example, the absolute value of x minus 3 is equal to 2. The first thing I do, I already did a step already. First thing I do is I draw two lines like this before I do anything to realize there's two equations to solve. So first thing I do is do this, so that's a cue to my brain. Okay, remember there's two equations to solve. Now for this one, it's not just x, it's x minus 3. You have to test whatever's inside the bracket. So x minus 3 could have been positive, but the x minus 3 could have also been negative. A common mistake is sometimes I see students put x minus 3, x plus 3. They change this sign. It's not that you change, it's everything in the bracket. This could have been positive, but that could have been negative. Okay, and then the rest, that's the hardest part. And now we solve. So for this branch, we have x minus 3 equals 2, so x equals 5. Then on this side, minus x plus 3 equals 2. Minus x equals minus 1, so x equals 1. So that should be really easy. Almost too easy for us at this point after getting through that rational unit. So enjoy the nice short solving of equations. Okay, are we done? No, we have to test those values. Again, use a t-chart. When we did this last time, some of you weren't using a t-chart, you were still using equal signs. That's a communication error. We don't know if it's equal. We use a t-chart to see if it's equal. Do you see the difference? If you start with an equal sign and then it's not, then that's a communication, almost a concept error, because you've equated something equal that's not. So the t-chart just saves us those procedural communication errors so we have proper work. Okay, so again, we put the initial question. The absolute value of x minus 3 was equal to 2. We had two values. We solved that x could have been 5 or it could have been 1. Let's test both of those answers. So 5 minus 3 is 2. The absolute value of 2 is 2. Yeah, they work. So x equals 5 is a solution. And again, another common error I see students drop the absolute value brackets too soon. So just follow your work through carefully. Okay, let's try this side. 1 minus 3 is minus 2. The absolute value of minus 2 is 2. So yeah, that works as well. So the two solutions we had, we keep both of them. X is equal to 5 and it's equal to 1. That's short, that's pretty easy. Not much more to it than that. We'll try a couple more examples. So again, the absolute value of x plus 3 is equal to 2x minus 4. First thing I do is do those two lines. You don't have to do them horizontally, but in my brain, that works for me. I split it. So I remember there's two equations I'm solving for. Again, the x plus 3, that could have been positive, but the x plus 3 could have been negative. And then the rest, I think this is grade 9 math. We're just solving for a variable. There's not even any quadratic equations, not at least in our lesson today. So if I bring that over x7, so x equals 7 is one possible answer we'll have to test. Then on this side, minus x minus 3. And then when I bring this over, I'm going to get minus 3x minus 1. Oh good, a fraction. Oh, I guess we weren't done with rationals yet. So there's two possible solutions, x equals 7 and x equals 1/3. Are we done? No, we're not. We're going to go to the next screen. We're going to have to test both of them to see whether we keep them or not. So I've already set up the t-chart and I've inserted the x equals 7, x equals 1/3. 7 plus 3 is 10. Whoa, the absolute value of 10 is 10. And this side, 14 minus 4 is 10. Yeah, so the x equals 7 we keep. That solution works. Let's try the 1/3. Oh, some fraction work. Oh, that's okay. We just got through the rational unit. We are fraction experts. Now we make a common denominator. So we get 10 over 3. The absolute value of 10 over 3 is 10 over 3. Okay, on this side, 2/3 minus 4. Make a common denominator. Oh, but look at, are these equal? No. This gives us positive 10 over 3, and this is negative 10 over 3. There's no absolute values on this side, so we can't just magically make the right-hand side positive. It doesn't work like that. So we reject it. So technically, I should go back on my screen. I can keep the x equals 7, and I reject it. It's extraneous. Okay, so just wanted to show you, that's why it's important to always use your t-chart and check and do your work slowly and carefully. Two more examples. Minus 2, absolute value of 3 plus 6x equals negative 42. Now we said that you can't have an absolute value equal to a negative, but we've got that negative 2 in front. So I'm going to do a pre-step. First, I'm just going to divide both sides by negative 2, so that should give me 21. So the first thing to do if you have a number like that, divide those out. And then, oh, I have a communication error. You can't drop the absolute value. So when you divide, negative 42 divided by negative 2 is 21. Now I have two branches. I still test both. The 3 plus 6x could have been positive, but it also could have been negative. Okay, and then we just work through. So 6x, we have x equals 3 on that side. And then on this side, when we work it through, minus 3 minus 6x equals 21. So minus 6x equals 24. So on this one, we have negative 4. So the two values we are testing are x equals 3, whoops, oh, and x equals negative 4. Okay, we're not done. We just have to do another t-chart. So we try that. Oh, I've already set it up and inserted. Now, the thing I wanted to point out is you should use the original question in your t-chart. I know when we solved, we divided out both sides by negative 2, but you should always use the original question when you test it in the t-chart. So we have 6 times 3 is 18, plus 3 is 21. The absolute value of 21 is 21. Negative 2 times 21 is negative 42. So yep, the x equals 3 works and we keep it. What about on this side? Whoops, the pen's not working. Negative 4 times 6 is negative 24. 3 minus 24 is minus 21. The absolute value of minus 21 is positive 21, but negative 2 times 21 is negative 42. So yep, that works. So for this one, we keep both. There's no extraneous roots. But I showed you that example, just how you deal with it if you have a number in front of that. Okay, and one last example. Now this example is not in your notes, I don't think, but there's a question like that comes up with it on your textbook assignment, and hint, maybe on your absolute value hand, and that's going to be coming in. So the first thing we can do, we want to test both branches, but I can stop right here. Let's look at this question. It says the absolute value of x plus 3 is equal to negative 11. Well, that's not true. The absolute value number is always positive, and there's no number in front, negative, that I can divide out or rearrange to change that. So at this point, I can just stop and say no solution. And again, if you just leave it blank, that's wrong. The solution is that there's no solution. This statement can never be true. Okay, so good luck with your assignments today and have fun solving absolute value equations.